Hello and welcome to Sofox does the Arduino Starter Kit, and this is going to be chapter 09, Motorized Pinwheel, and this is pretty much where we left off last time, and now I just have to take all these out because they're not really needed for this exercise. Now, when I deal with the motorized pinwheel, the most important thing you need to know is that this is a motor. Yes, motors are pretty important for learning about motorized pinwheels. The key thing is, this is a new component, and it is different from everything we've done before. Up to now, we've had sensors and LEDs, and they were all fun and good. But, none of them take up much power. LEDs are great because it takes very little power to light up, to create a light. But the problem with motors is that they take up a lot of energy, and pretty much more than the Arduino can supply. Now, you might think, hey, this is fun. We can just, plug... Oh, shit. I'm actually going to do it, aren't I? Okay, I'm only doing this just to show you how not to do this, because you can literally damage your Arduino by doing this. You probably think, oh, I just plug one into negative and one into positive, and then this motor... Don't do this. Even I'm not sure what's going to happen, but let's see. Okay, so it does actually work. You saw it working there. You see there we are. Okay. Don't do that. The reason for it is that this motor, even though it kind of works, is putting a huge strain on the Arduino and how much voltage it can put out. And it gets worse. There's something called what's called back EMF, which is kind of interesting. Basically, you're familiar with how a motor takes an electric current and turns it into this nice little spinny thing, right? But you may not know that an electric motor works the same in reverse too. If it works one way, it can work the other. See that? Just by spinning the motor with my own hand, it's converting motion into an electrical current. Motors work both ways. They can work both as a motor can work to turn movement into electrical current or current into electrical motor, into either motion into an electrical current or turn an electrical current into motion. Now, I've seen a dynamo, as in like one of those crank up things and light things up, work the same. I got a dynamo and I said, hey, look at all this fun stuff. I'm cranking this thing and powering a circuit using my fist. And then one smart guy came over, hooked it up to a signal generator, and actually got the dynamo moving on its own accord by channeling an electrical current through that. The point is, if you supply an electric current to a motor and then the motor stops, the motor will keep spinning but through its own momentum, but then that electric current that it generates will go back into the circuit in the opposite direction to which it received it from. This means that by spinning something big and then stopping it, and as it continues to spin, it will actually send electrics back into the circuit and could damage the Arduino. So you do not do that. You use what's often a diode. This is a one-way street. A diode only allows electricity to pass in a single direction. And with diodes, you can try to eliminate some of the nasty back EMFs. Now, there's a lot of little things you can do about this, but I think I'll skip to the main point. Now, you might ask, wait, if we're going to do a motor and we're not going to power it by the Arduino, how will we power it? The answer is through one of these. This is a 9-volt battery. It should say it right there. 9 volt. And the Arduino Starter Kit comes with one of these. You have to supply your own battery. And the great thing about these things is that 9 volt is actually much higher than what the Arduino supplies. We are through the magic of this 9 volt battery. Okay, do you want to see what happens when we put 9 volts through an LED? You should not do this. You should definitely not do this. Okay, this is longer in plus, longer in minus, and thing in plus. Okay. Don't do this. Don't send a 9 volt current through an LED. I think we broke it. Yeah, I think we may have burnt it out. Ow, it's hot. Okay. Don't do that. LEDs can just about cope with 5 volts. You shouldn't be doing 9 volts. But when we put plus to, there we are. Plus to plus, negative to negative. And now if we plug these in, this should give us a motor powered directly through our 9 volt battery. There we are. Now notice that this is far faster and far more powerful than what the Arduino was supplying. That's because A, it's got more voltage, and B, I believe it's able to, I think there's a limit on the Arduino. It can only provide 40 milliamps of current, so it's much higher with the battery. So that's spinning. Now there's something you're not going to be able to see just from this, but trust my word for it. It does and doesn't matter which way that you pass the current through a motor. It doesn't matter in the sense you're not going to break it, but if you change the direction the current passes, you'll change the direction. So this is one way, this is the other. So pass the current in whichever direction you want the motor to actually spin. So that's enough of a preamble. Oh yes, you want to know, wait a second, if we can't do this, then how are we going to get the Arduino to control the motor if it's going to be powered completely separately? We can't just send a current like through one of these pins into the motor and when we want it powered and then just cut it off when we don't want it powered. How do we keep it going? The answer is we use one of these, a transistor. Transistors revolutionized computer industry. Previously it was just vacuum tubes, but a transistor is basically a switch. You put a current through the middle pin and it opens up between one side and the other. It basically uses electricity. It's like a button, only instead of pushing the button manually through physical force, you push it through an electrical current. And the electrical current triggering the transistor can be totally different from the electrical current going beside it. Although I believe there's some very complicated maths that determine exactly what you can and can't pass through a transistor. But as you can see, well, there's many different kinds. There are always things. When you provide voltage to one of the transistor's pins called a gate, it closes the circuit between the other two pins called the source and drain. This way you can turn a higher current voltage motor on and off with your Arduino. Let's get to the actual diagrams. So, got most of this set up already. Well, I mean, kind of part of it anyway. So, and we'll actually use this. Oh, great, we get a button. Or we can just use this existing thing and get that nice little button there. Okay, and that is a 10 kilo ohm resistor, which we have somewhere around here. Yes, there we are. That 10 kilo ohm, brown, black, and orange. And this is just a very, very simple, hey, it has this, yo dude, has this switch being pressed. And for some reason, they've got this resistor going to this section here, and then going straight to, and then having a wire connected to ground. But I see no reason, let's say, cut out the middleman, let's just have this, let's just have it, yeah, they have a nice connection here. I just say, cut out the middleman, let's just go straight from one to the other. Now I still need to actually detect where this button is pressed, so we'll link it from 2 to the motor. Sorry, 2 to the switch. Yes, there we are. So as you can see, this is just a very simple detect where the switch is pressed. Voltage comes in here, and then goes through here. This, if the button is off, then this is connected to ground using this big, really hefty resistor, so therefore it's going to be 0. But when I press the button, it gets connected with voltage, and then it gets switched to a 1. Simple switch detection, that's all. Next up is this, and I'm trying to figure out which way around it is, but I think it's this way. So first of all, we hook this to in here. Okay. So that's 1. Connect the power and ground, and momentary switch to the board connecting one side. Yes, I've already tried to connect the battery here. Oh yeah, there's a weird thing that they need you to do, and I've seen this happen in other places before. They want you to connect the ground of the Arduino to the ground of the, I want you to connect the ground of the Arduino to the ground of the battery. Now, this never quite made sense to me, because I thought, hey, I thought we were meant to keep 2 different power sources separately, but sometimes systems won't actually work if you don't do this. There we are. Actually, that's almost too long. I want to short a cable so it doesn't get caught on something. There we are. 1 ground to 1 ground. I said 1 ground to 1 ground. Okay, that's close enough. Yeah, ground to ground. So then we need to work on how the transistor works. Sorry. When using circuits, you have to connect when using circuits at different voltages, connect their grounds together to provide common ground. Plug 9 volts, snap in. Okay, we've already done that. Place transistor on board. Look at the components so the metal tab is facing away from you. Connect digital pin 9 to the left pin on the transistor. This pin is called the gate. So, it's not sticking in properly. There we are. That took a little bit of force, but nothing major. So we need to connect pin 9 to the gate. Oh, okay, so the left pin is the gate. I thought that the middle pin was the gate, but I guess in this case the left pin is the gate. Change in voltage on the gate makes a connection between the other two pins. Connect one end of the motor to the middle pin of the... Connect one end of the motor to... Oh, one end of the motor to the middle pin. Okay, they're saying I should connect it there, but screw it. Alright, yes. So connect one end of the motor to the middle pin of the transition. This is called the drain when they draw next to it. Yes. Connect it to the source. This is ground. Okay, I'm still just making sure I get this. Because there's a diode here, and I'm not sure how that fits into things. Oh, yeah. This pin is called when the Arduino activates. Okay, how do I do this? Wait, this bit... I'm confused. Place transistor board. Connect digital pin 9 to left pin. This is the gate. A change in the voltage in the gate makes a connection between the other two pins. Other two pins, being ground and, I guess, positive, kind of. But they've connected... Okay, I think I've got it here, sort of. They want a diode here. Why do they want a diode? Okay. Okay, I think I've got it now. So this is the transistor. We've already connected by 9. We can, by changing the 1 and 0 on 9, we can decide. By changing the 1 and 0 on this pin, we can decide where the other two pins connect. And we are going to connect the middle pin over to here, and then to well, actually, since it's kind of, it doesn't really matter the color, but there we are. We've connected this to the middle pin, which means it's connected to the motor. Now, next we need to connect the motor's voltage supply to the motor and the breadboard. Last component is the diode. The diode is a polarized component. It can only go one way at the circuit. Notice that the diode has a stripe on one end. The end is the negative end or cathode of the diode. The other end is the positive or anode. Connect the anode of the diode to the ground of the motor and the cathode to the diode of the power. So I guess this goes here. Oh, wait, it's running already. It shouldn't be. Wait, how is this running already? It shouldn't be running already. Ah, don't tell me. Okay, I gotta power this off, I think. There we are. There we are. So somehow it was supplying a voltage to 9. So cathode. So we need to stick the negative. Okay. The other end of the positive or anode. Connect the anode of the diode to the ground of the motor and the cathode to the diode to the power. This may seem backwards, and in fact it... Thank you! Sorry. This may seem backwards, and in fact it is. The diode will help prevent back voltage generated by the motor from going back to your circuit. Remember, the voltage will flow in the opposite direction of the voltage that you supply. Okay. Yes. So, yeah, it is backward. Okay. So, if I've got this... LEDs are diodes too, in case, just to let you know. There are many kinds of diodes, but they all share one trace. They allow current to flow from an anode to the cathode, but not the reverse. So, you know, basically, yeah. That's to stop back the EMF. So this should be pretty straightforward. It's just a really simple circuit just to set things up like this. So, let's dive in. I mean, switch pin equals 2 and motor pin equals 9. So this will simply read whether the button is pressed or not. Okay, so that's a really simple way of doing everything. I'll just upload everything. I'll just confirm that I didn't write any. Okay, there we are. Once again, accidentally capitalizing stuff is my weakness. So we did. You're right. I didn't. Int switch state equals 0. Okay, so back to this again. Back to getting everything done, and if I press this button, the motor should run. And there's your answer. When I press this button, the motor does run. So, the great thing about this is that it's actually such a simple program. All we need to know is when we press this button, 9 goes live. When 9 goes live, this transistor connects. It connects the ground to the ground of this thing here, and then everything works. Now, I have a feeling that if I switch this around, I'd accidentally get a short circuit, but I'm not sure. Oh, yeah. So basically, let's trail the circuit. Obviously, the battery, so it goes through here, through the motor, through there. Now, it doesn't go through here because the diode stops it, but it goes through here, and then it has to go through the transistor, which only happens if this thing is set light, and then it goes through here and then back around. So that way, this is powered. Sorry about this, it's magnetic, of course. This is powered by this. But I hear you say, what happens if we want it to go in the other direction? Well, we simply take out these cables and reverse them. Because it really doesn't matter to the motor. Now, I don't reverse these cables because I've already hooked up the two negatives on this end, and that would have become screwy. Now, you might think that, okay, this is fun. That's a very nice bit of that's a bit of fun, but this starter kit also has a bit of arts and crafts to it. So let's take a look at what they've got in store for us. Ta-da! So let's see if I can actually do this, which I probably can, because, you know, arts and crafts. So you put these like here. And you wait a second for it to get in properly. There we go. And we put this bit in here because I think that's where it goes next. And you hear a snap, but you hope you didn't break it. And then you go up to the motor and you stick this end in here. Then you try to rotate it slightly until, then you try to ease it in. Then you try to stuff it in, and then you, there we are. Okay, so that's nice. Let's press that button again and get it going. So that's good, but can we go further? And the answer is hopefully we can, because they've also given us this little thing here, and they say, I think we're meant to, sorry, not the CD, I got the CD from somewhere else. I got this little thing here. By the way, you might think this means my birthday is 1987, because that's normally who these things are for. But it was actually someone else's birthday present who they rejected, so let's not go into that right now. There we are. So, this is all arts and crafts, paper craft, so to speak. I think I meant to use glue here, but who has time for glue? You know, people who, like, the glue is just used by people who actually want to do a good job, you know? Yeah. And, there we are there. Okay, this is almost not working. Screw it. What happens if we just stuff it as it is right there, right now? There we are. That's good enough for now. Let's see it spin. I think that was a successful test. Okay, why don't we just stick this directly on? Okay, I think that's how the pinwheel actually works. So I hope you've had a fun time with this, and I hope I've introduced you to how motors work, because they are pretty cool. All right, that's enough for now. Next chapter has a zoetrope, which has a lot of the similar things, and I'm pretty sure it's going to be even harder for you guys to see. So yeah, this has been Sofox with the Arduino Starter Kit, just showing you how to make a motorized pinwheel.